introduce my presentation about the next network presentation. I'm Yoshihiro Nakajima. I'm a director of NFV development team. And let's go through our current NFV deployment for core network system. Yeah, I think that you might see my slide open. And I think so our architecture is based on the HNFV. And we are running on the OpenStack and APC, 5GC, IMS on top of our system. And this is a real merit of using the NFV system for core network system. So the cabinet reduction, the agility improvement, and connectivity improvement, improve the reliability. So I think the improved reliability is one of the merit because so we can proceed much efficient operations using the healing mechanism to realize a higher availability and reliability on top of the virtualization technique. So this is a number of our NFV deployment. So we are reaching to the up to I think the 90% is fully virtualized, and next year I think fully virtualized from the 4G system, and the infrastructure is getting bigger. I think currently we are running of the more than 500 kilo 1,000 big budget CPUs in our nationwide services. Okay, so let's talk about the next step in the network virtualization. So in our future directions, from the core network system are fully virtualized, and we are extending our capability to all the virtual radio access base station. And another direction is about the cloud native. So the application goes to the containerized, and how to realize a much efficient and much flexible deployment using the container orchestration mechanism. And of course, we are facing the limitation of the energies and the floor space and the data centers. We are trying to improve our infrastructure to meet the traffic demand for the future network. And also, the automation and the CI/CD processes are one of the also important things to realize a much efficient and much flexible deployment in the nationwide deployment. So that's why we are trying to conduct various the researches and the studies on the core network system and the build side. And for the 2023, 2030, we are trying to realize carbon neutrality. So that is a big challenge for telecom sectors because the traffic is getting bigger, and we need to invest lots of the resources for the system. But now we are trying to realize much efficient, 10 times much efficient packet processing and the user frame processing and control processing. And that is I think the many operators need to address. And for the vision, we are trying to leverage the cloud native ecosystem to realize a much extensively cloud native industry solution such as Kubernetes. And we believe the cloud native ecosystem is about adding the values for the telecom. And also, we are working on the standardization, especially the HNFV and 3GPP and ORAN, to harmonize specification among the several organizations. So right now, the system is much monolithic. But we are trying to realize a fully cloud-native application using the much cloud-native technology like PaaS. So everyone think in the previous sessions, you can see the many decompositions and the orchestration on top of that. And so I would like to mention the two topics. One is a hybrid cloud with hyperscaler cloud. I think the many operators are getting interested in how to use AWS or Microsoft or GCP for their core network system and radio side. So actually we kick off this POC with the partner vendors, NEC and AWS. So we have conducted the POC to run the 5G services on a hybrid cloud based on the end-to-end fully cloud-native network architectures. So you can see the three topics. It's a very challenging for items. First one is how to realize the hybrid cloud scenario using the on-prem cloud and hyperscaler cloud for the high reliability and robust system for the mobile system. And the second is about how to change the existing monolithic application to use the managed hyperscaler cloud functionality like a PaaS or CaaS system. And the third item is about how to realize a much efficient or much energy efficient user plane processing and control plane processing using the state-of-the-art of recent servers. And so this is the basic design of the 5DC from the monolithic to the much cloud-native way. Like as I mentioned before, the many operators try to provide the CaaS and PaaS system on-prem. And if we move to the existing architecture to the hyperscaler cloud, you can see the many the interesting features. And we try to leverage such a functionality as much as possible to reduce the operational cost. So in these cases, we run on top of the AMF and SMF, UDMA, AUSF with the PaaS functionality. And this is the result. So we successfully onboarded the 5G C-plane and the U-plane in hybrid cloud. And also, we complete the high-level carrier-grade redundancy design for hybrid cloud leveraging the AWS on-prem NFV cloud. So that is much important because the hyperscaler cloud sometimes costs too much. Especially for the data transfer, it's much costly. So that's why we need to set up the, how can I say that, much cost-effective way using the on-prem and the hyperscaler cloud. And also, using the recent technology of the new generation of CPU, provided by AWS Graviton. So we achieved a much sustainable and much energy efficient processing using the existing conventional x86 servers. So in this year, we measured 72% reduction to the existing the servers. So that will be very beneficial for us because in the less energy, you can see the double size of the capacity. And also, we measured the 20% performance improvement using the same the factor of the x86 servers and the ARM servers. And we are trying to develop this scheme for the commercial I think in next few years we will start the commercialization of the 5G on the hybrid cloud. And the next topic is about the virtual radio access. As I mentioned before, we sustain the merit from using the NFV technologies. So we are trying to apply that knowledge and technology to the radio side. But you know, the radio side, we need to consider the fully distributed and high real-time and high performance processing on top of the x86 hot server. And also, regarding the distributed environment, we need to care about the end-to-end orchestration mechanism. And also, so there are lots of requests or requirements for the cloud infrastructure for virtual LAN. So we need to address such issues. And another aspect to be considered for the operator side. So we try to the orchestration system as simple much as possible. So in the core side, we use the HNFV specification, and we try to apply that idea to the core network, so radio side. So that's why we try to realize one platform for the VLAN and the core network system. And you can see the some specification document in the some interfaces, and it's an initial design, and we respect the standard, existing standard like HNFV and ORAN, the 3GPP-SFI, and we are trying to realize the PM and container application, because existing the service we need to continue. We need to maintain the infrastructure even in the PM. And many operators said as we also try to decouple the pass functionality to the application. And you can see the many challenges, especially for VLAN realization from a virtualization and orchestration point of view, and energy saving, and the OTDMS. It's about the SMO and deployment interfaces, and there are lots of, especially the acceleration. It's the interesting features to support the VLAN application in terms of the all-cloud aspect. And so this is a basic design of implementation for SMO and all-cloud based on the existing specification with the ORAN and HNFV. And we use the AWS ETSI Anywhere to set up Asori to realize the all-cloud system with hardware acceleration support. So in this figure, you can see the red boxes means a component of the all-cloud. And we try to realize the fully distributed all-cloud environment using the existing specifications. And I think also we try to use the open source Kafka as a generic VNFM functionality. So to sum up my presentation, so DOCOMO try to go together with many operators because, as you know, the interesting message from the Africa. So if you want to go further, go alone. But we would like to go further so that we go together. So, so that's why we are trying to engage the many places to get the knowledge and feedback from the development to push the network correctly. So thank you.
On behalf of the chair, any question here? Just one. James, so your time. Absolutely, you have seen it for whole afternoon.
Thanks very much. A very interesting presentation, Yoshi. So you said that you've done this proof of concept with AWS and NEC. You were able to host virtualized RAN network functions in public cloud or in a hybrid of public and private. And then in a few years' time, you thought that potentially that could go into production, so real live customer traffic. So what do you think? What is feasible? What is practical? What is cost efficient? Would you assume in 5 years' time that 1%, 10%, 90% of the traffic would be hosted in this way? Just give us an order of magnitude of how significant this sort of scenario of using public cloud to host network functions. How big a part of your architecture should it be, or could it be?
Thank you, James. In terms of the cost, just for the core network system, of course, the user plane is not visible because the transfer fee is much costly. And but even in the signal control plane, that works well. Even in using the AWS infrastructures. But so we have the type of discussion on how to reduce the cost, even in the hyperscaler cloud or core network system. We are trying to use the cheapest hardwares like servers, or we optimize the processing and the data transfer between the network system. Of course, we are conduct the optimization in the design, the whole design of the architectures. And VLAN deployment. So in this scenario, we can leverage the IT sector's scale in the AWS. So I think that will be much efficient. But I don't know. In the few years experience, so we conclude the merit using these architectures, because even in the first deployment scenario, the upgrade cost and the maintenance cost is not how can I say that considered. So we need to consider the long-term support or long-term maintenance or cost for the deployment.
Okay, so just to clarify, potentially for control plane traffic, but it's not considered for user plane traffic. That would still be running over your own.
Yes, yes. But Japan has a big earthquake somewhere, and even in the one the hyperscaler cloud affect the fiber card or something, so we need to ensure the connectivity to the customer. So that's why we need to distribute the network system in several sites for the natural disasters. And I think the main traffic will be offloaded to our on-prem system. But in the sudden surge, traffic will be offloaded to the hyperscaler cloud. So in some cases.
Understood. Thanks very much.
Yeah. So thank you. Yeah, this is a realistic question. Do you have signal is strong? Have you ever experienced? What do you think about it? Because you're thinking control plane, you have certain percentage.
Yeah,
might
That's a good question.
Signal storm.
To prevent the signal storm, we designed the capacity management of the number of UEs or number of sessions in distributed web.
Okay, so you already, I mean, prevent that kind of
Yes.
the burden of the signal storm. Okay.
Yes.
Anyway, interesting discussion. All right, so thank you, Yoshi, and can continue to share the next one.
Thank you. And
Give